Okay, we want the area between the 2x cubed and the 4x graphs. Okay, and to construct a graph, we don't make a table with lots of points. Not for these basic functions where we pretty much know what the behavior ought to be, or should know. So if we don't, we want to get that. Just for the x cubed function, which is very basic, x squared and x cubed. The x cubed function is going to have, just plain old y equals x cubed, is going to have points -1, -1, 0, 0, and 1, 1. It's really about all you need if you understand the shape of the graph, just to plot down a very approximate graph. Now there's more to it. You should know what happens at -1/2 and -1/2, and also probably at 2 and -2. That gives you the rest of the shape. But we have to go through those points. I kind of missed them, but you know, there's the point that should be, the green graph should be going through that point. And, I'm sorry, the white graph should go through this point, but I kind of missed it. And this point and this point, okay? And it has the shape of the cubic function, which we need to understand. The 2x cubed function then will go through, instead of 1, 1, through 1, 2. And instead of through -1, -1, through -1, -2. So there's our 2x cubed function. Okay, our y equals x 4x function. Well, we start with the y equals x function, which goes through these 3 points. I missed this one. Okay? And then every y value becomes 4 times as great when we multiply y equals x by 4. So we get a 0.14 and -1, -4, and the graph is going to then kind of go through these points and these points. And if we understand that the 2x cubed function is going to get arbitrarily steep and very quickly, we understand that it's going to have to intersect the graph of this linear function. Okay? So the question is, what are the coordinates of these 2 points? Now the way I've drawn the graph, it looks like this point is closer to the x-axis than this one is, but there are symmetries involved here that indicate that it should be the same distance. So it's just that my graph isn't particularly accurate. What my graph has indicated, though, is that there is a region that's bounded by the 2 graphs. Since we have to have an intersection here, and since the slope of the x cubed function is instantaneously 0 at this point, and you can, you know, your first semester calculus would have established that, but obviously the derivative of 2x cubed is 4 sine 6x squared, and when x equals 0, that's 0, right? Another way of seeing why that function levels off for an instant at the origin. We need to understand that about the function. Because of that and the constant slope of the 4x function, we know that the 4x function will be above the x cubed curve here and below the x cubed curve down here. So there will be 2 subregions bounded by these 2 graphs. And then beyond this, the 2 graphs don't meet again, so they don't enclose any more area here or up here. Okay, well, once we understand that, the question is, okay, where do they intersect? Where do they intersect? I say where, I really mean what are the intersection points. Okay? So see if we can figure that out.